Hello, good evening. This is SMG ISMA. You're all welcome. This is going to be the link that we'll be using throughout the remaining classes, and hopefully we don't get hacked like we were last week. Engineer Manzi is going to take this class for today, and he's going to kick off shortly. We'll give in for like 3 minutes, or at exactly 5 of 6, we'll start the class. Yeah. Okay. At exactly 5 of 6, we'll kickstart the class, and then yeah, we see how it goes. Today we will be picking up from where we ended on advanced mic techniques, and he will run you through different specs and phase, and then other things that deal with softwares. Okay, let's wait for a few more colleagues. I'm only seeing 6 of us, which means actually 4 of you have joined, because the other 2, it's me and then the host account of Malika Studios that is signed in. We are so far waiting for other colleagues to join, and then we'll kickstart in 3 minutes from now. For now, stay blessed.
Okay, welcome everybody. Last time we didn't finish on microphones, and we shall just do a quick recap on what Mr. Isma talked about, and also giving you a refresher. We've just been a week away. We missed last week, and the way this is going to run, we're going to go through. If you have questions, you will wait, and you will ask the questions at the very end. So get your notebook close, and we get started. Write them down, and we shall have a section where you guys will ask different questions. Okay, so I'm doing this to save time because we are finishing on microphones and touching a bit about software. Okay, so from last, let me just quickly run through summary for last class. So we talked about microphones, what they're used for in recording, live sound, broadcast, and used for communication. And we talked about a brief history of microphones, how they began, and each century, what was evolving, what was changing, and these engineers that were brilliant, bringing out new technology, trying it, making things work, until the 20th century and today's era where things are still evolving. And then we talked about basic principles. We must, as a sound designer, if you're capturing sound, you have to definitely know how sound works. Okay, and you must know how sound behaves at the very source, and microphones are the tools that we use to capture sound. So you must know how microphones work. You must know, how they're built, and because how they are built affects how they behave in different situations. Okay, so we talked about the key components. We talked about how each of them process signal differently. Looked at the types of microphones. Now we only gave three. There are more than three, but I actually want you to differentiate when we talk about types of microphones and we talk about dynamic microphones, condenser microphones, and ribbon microphones. It's different from when we talk about polar patterns, because sometimes they're like, this microphone, it's a cardioid, and you meant to say it was a condenser microphone. These are different things. So the types of microphones, we call them types of microphones because of the way they are built, the technology that they are designed. So one could be a dynamic microphone. We talked about how a dynamic microphone is and how it works. It has a diaphragm and a magnetic coil that when you speak, that friction and movement or up and down of the coil creates the electric signal that flows through the cable into your mic preamp. Condenser microphones, on the other hand, need extra power so that the plates are sensitive to sound. When you speak and there's vibration on the plates, that difference between the positive plate and the negative plate charged differently will create the energy that we will perceive as sound. And then we have ribbon microphones, which have a thin, and these are delicate, and these are also very sensitive and fragile, and they're usually used in studios. And then we showed examples here. These are, you have a dynamic microphone. Usually these ones can take a beating. These ones are very durable. They are strong, as we shall see below. And we have condenser microphones, and we have ribbon microphones. You can see the image. Types of microphones. Now, we have a different way we can categorize these different microphones, depending also on the technology. Continuing from what we talked about before, we have USB microphones, we have shotgun microphones, and lavalier microphones. This is, when we say type, we are talking about how these microphones are built. And then we can see we have a USB mic right there. We have a lavalier microphone right there. And we say lavaliers, the name comes from how we use the microphone. We put it at the lavalier, which is like that collar you have on your clothing. When you put it on, you hide the microphone beneath, and because it's known for picking sound in that way, so it's called lavalier or lapel. And then we have polar patterns. Then we have cardioid, omnidirectional, bidirectional, and shotgun microphones, where we have images here. And this is now how the microphone behaves in the way it captures sound. So omnidirectional means it is capturing sound from all directions with equal energy. Bidirection means, or some people call it figure eight. Yeah, it's easy to remember. Figure eight microphones can pick sound from both sides, which makes them perfect for duets. So you have two people and you want to capture sound in both directions at the same time. And then we have cardioid. Cardioid comes from the word cardio, which is another word for heart. Then we have supercardioid, and then we have hypercardioid. Same, these are still cardioids, but specific cardioid. Supercardioid, we see, doesn't pick so much from behind. Hypercardioid picks a little more from behind. And then these graphs are usually on all the microphones you buy. So you will find this information on the microphone. They usually even put them on boxes. It's information that you access first time you go to buy a microphone. It's very easy to access. It's very easy to see, and it gives you the angle at which the microphone is picking sound from and how it will capture it. Yeah, either in a figure eight, and the angles are just there. So, and then what you does those numbers you're seeing in between, it's decibels. Okay, and we talked about decibels is the unit measure in which we measure sound. Then we have microphone components. This is how microphones are built. So we have the diaphragm capsule. We have the voice coil for dynamic microphones. There's a magnet. There's a preamp. And these are the two types of common types of microphones that we'll find in most situations. So we'll have the first one being the dynamic, and you see it has a coil. That is the mic that you will hold in your hand. They are usually less sensitive, so you'll have to hold them close to the signal source so that you have enough energy to actually mechanically vibrate and move that coil up and down on the magnet. Then you create electricity. And then you have condenser microphones, and we can see these two plates. There's a back plate, and then there's this diaphragm that is in front. So when you speak, vibration will create a charge that will be converted into energy that we perceive as sound. And then we have the grill, which is that mesh that is on top. We have the housing, which we usually hold. And then we have pop filters. We saw pop filters. We shall see an image below. And we have shock mounts and windscreens, which are all demonstrated here. Yeah, and you have the document. You'll go through all this. I'm just giving you a recap quickly. And then we have microphone stands and cables, and we have examples right there. Application, we use microphones in studios, we use them in live sound and in broadcasting, we use them in film and video production, we use them while we are shooting our cool TikTok videos. Yeah, and in communication on our phones and in field recording. And so we had here, what are the factors you need to consider while choosing your microphone? These, you need to know the purpose, you need to know the environment you're going to use this microphone in, and obviously your pocket does determine what kind of microphone you can get. There are microphones that are super expensive, and it will be illogical for you to buy an expensive microphone. Yet all these other microphones can serve the same purpose. So yeah, save your money and get something functional. Knowing this will save you a lot. And then we have microphone types. We've talked about that already. You have to know the type of microphone before you buy a microphone. And then you need to know the polar pattern, which we've talked about already. And then we need to know frequency response. This is very key because you might buy a microphone that works for a bass drum and you want to do voice on it, and you will hate all microphones just because you bought the wrong microphones. And if you tell people that I was part of this Spectacolo workshop and they taught about microphones, and then you proudly present your bad microphones, people will not be happy with you and we shall be disappointed. So that's why we're telling you, you need a microphone that is, you know, if it's a vocal microphone, you should know, what does a vocal microphone do? Uh, and what does a microphone I need for low end and bass? What microphone is that? How do I know what is the right microphone? That is very important information. And yeah, obviously you will think about, how am I going to connect this microphone? I just have a computer and I want to record a podcast. Maybe a USB microphone is much easy. Maybe I just want to do sound effects and then design them and prepare the stuff for theater. Maybe a USB microphone is ideal for that purpose. Okay. And that is the connectivity of the microphone. And then of course, does the microphone require phantom power? Do I need extra tools to add? For example, you have a figure 8 microphone. You might actually need a preamp and a cable that supports that configuration. Yeah. Yeah, because it's getting two signals and you have one cable. So you need something that can play around with this and be able to give you the two channels the figure 8 is giving you. So this is how you tell how a microphone behaves to frequency. Now, this is volume. This side here is volume, and it's usually in dB. Okay, so we can see there's 0 dB, and then there's positive 10 here. We have negative 10, and that is going to be our scale. This is a very ambiguous scale. It's a big scale, but it gives you an idea of a negative and positive scale so that you know if the microphone is boosted or if the microphone's frequencies are cut. Okay, so we have a relatively flat response in the first microphone, that is the Shure SM81. So that microphone is relatively flat, and it's very difficult, by the way, to have a 100% flat microphone. The more we call that precision. If you have a very precise microphone, its application would work maybe for engineers who are analyzing rooms for acoustics, who are analyzing a PA system, stuff like that, because you need a microphone that is as flat as possible. When you go to this Audix ADX51, this microphone is boosted in the high end. And remember, last time we talked about the voice having its a lot of intelligibility at around 2K, 3K. Our ears are very sensitive to that area. So if you want a microphone that can actually, bring out a voice with that enhancement in those regions, especially when you have a lot of things happening, you definitely need a microphone that has an enhancement in the high mids. And there's a bit of clarity with this boost right here. Here, it's a range where you hear just air, something like, okay. So it will sound good on vocals when you have that. It just gives an illusion of clarity and crispiness. When we have the AKGC 451, now those names are given to microphones. When you start working with different professionals, they will actually just tell you, give me the 451 or 451B. They will just tell you the name of a microphone, and sometimes they expect you to know that. But if you don't understand, you're like, oh, what mic is that? They will explain, they will tell you. So in case you are in a place where people are speaking code of microphones, just ask, please, can you explain a little more? And they will tell you, we are talking about this microphone. It's an AKJC 451. It's relatively flat. Now they will tell you. Engineers love talking about their equipment, so they will love to teach you everything about that microphone. So if you ask, you'll always get it. That's one tip. That if you want to learn more about sound, ask these guys that are working in sound. Most chances they really want to share because they're constantly researching and reading. So anytime they find someone who is interested, you get it hot. And finally, we have the Audix D2. That is a drum mic, and it will pick a lot of low end. You can use it on basses. And sometimes people think bass is all about the bass, but it's actually not. Like, for example, if you're holding a double bass, this instrument Yes, it has the bass, boom, 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 boom. But then there's where the thing attaches the string and plucks. There's that that sound is in the high range. So that's why that microphone is designed in a way where it will get the low end and it will also get the nice attack in the high end. So that is that impact when your finger just taps on the string, there's that bright sound that it has. So the mic should be able to, bring that out. And that's why you see that mic designed like that. So by knowing this, you know the polar pattern, you know how the microphone connects, you should be able to choose the right microphone. If you have a question, please write it down and you'll ask these questions after. Yeah. And then we talked about, yeah. And I think Ismail will be in the chat and he will be helping you on some of the questions and letting me know if some need to go through here with me. So when you buy the right microphone, you must know how to use the microphone. So setting up a microphone is very important. So where do you place it? I'm using a dynamic microphone, and imagine if I had this microphone so close, it'll be sounding like this. I'll be sounding like this. Now I'm so close, and now I ask you to come with headphones. I hope most of you are in headphones. Thank you, Josh, now for the headphones. I can see you. And everyone else that is in here that has headphones. Let me see. Let me see who has headphones. Most people are off. Most people are off. I can't see their videos, but yeah. Yeah, I will appreciate the one that I'm seeing. I don't know the Vanja. Vanja. Yeah. No, I don't see Vanja. I see just now with headphones. So you, yeah, thank you. So you can hear the difference in this microphone. It's more muffled. I'm so close. My voice might sound much deeper, and it's not ideal. It's not the best. Okay. So but if I have the right distance from the microphone, you can hear the high end of the microphone and the right low end that matches my voice. So techniques having let me extend this a little. Okay, so yeah. And by the way, we can use this as a technique. If you want to record a beatboxer that is going to provide effects for you on stage, you didn't want to pay a band and you have a beatboxer, there's a way they'll hug a microphone and do cool stuff like yeah, yeah, stuff like that. So they will need now to use that proximity. Come so close to the microphone so that they can yeah, do cool stuff. So knowing what kind of mic to do that is also very important, because if you use a microphone that is not ideal for that, the effect won't really be nice. Your beatboxer will hate you. Um, you don't want to be hated by beatboxers. So we have stereo recording and noise reduction. So the way you use the microphone, by knowing the polar patterns, we might be like, oh, okay, let's put this microphone opposite, let it face against the noise. And actually, that's how we use microphones. People think it's where you point the microphone, but it's not only where you point the microphone, it's where you point the mic, um, how you point the microphone. Sometimes it's you need to point the mic away from some things. If you are doing stage sound, you need to point the microphone away from the stage monitors, like we saw last time, because if the mic is there picking the singer but also picking their monitor, it's not going to be a good experience. So using microphones is just more than just putting them, okay, let's go. It's consider all these other things. The room, let me point it away from that wall. It's very reflective. There's a bathroom next door. I'm not going to point the microphone in that direction. I'll point the microphone in the opposite direction, and you'll have much, much, much better results. Yeah, and now we have These are some configurations of stereo mic. These are advanced techniques that you can use. And in your free time, you can go and search more about them. But to give you maybe an idea, it's stereo. We said stereo is anything that has stereophonic sound, so which is sound for both ears. And as you can see in these images, we have left and we have right. So that means the sound is we deliver sound delicately for one ear and another ear. And it's the same sound but slightly different. It's the way we hear the environment. We don't hear things in mono. We actually hear time differences. One ear, if something is making noise on the left ear, let's say you're stranded in the forest and there's this lion that is coming to you. Um, if the lion is coming from the left ear is going to be the first one to receive that sound. And in a few microseconds, very, very few microseconds, the right ear will also hear the second sound. And that will tell your brain where the sound is coming from. So stereo miking in sound design is try to emulate an environment that the brain will think that the sound was coming from a certain direction. So to create an immersive experience, immersion. Okay, and usually our art, where we have theater, film, music, we want to immerse the audience as much as possible. So we'll have some of these techniques to enhance our miking game. And as you can see, mic one, we have a polar pattern like a cardioid. And mic two, we have two cardioids and that are wide. And then mic three, these are two figure eight microphones that you're seeing that are creating this circle. And then the last one is also, we have two, yeah, one cardioid and a figure eight. So you have an effect that you will achieve with different microphones. Okay, and I will continue to phase. Okay, when you start introducing many different microphones, you're going to suffer. Just excuse me a bit, just need to adjust this microphone to practice what I'm preaching. Microphone placement. Okay, maybe part of miking is you need to be comfortable. Don't mic, don't put a microphone in a place where you're very uncomfortable. It is going to affect your performance. So part of the placement technique is you need comfort of your talent, of which the talent could be you, and so that you don't break your back, your neck trying to record things. Even your voice, functions much better when you have good posture. So make sure the people you're miking on stage are in the right posture if they are to deliver very well. Okay, and then so we were talking about phase. So phase is where the sound is at a certain moment in time, and that is on a waveform. I'll jump to here. We have you can see my cursor very well. So let's look at figure A, where we have so a wave. We're in the first class we talked about waves and how sound travels. So it will create a wave like this. So it's traveling in this direction, up, down, up, down. So this is what we call phase. At a certain moment in time and the direction of where the waveform is what we call phase. So when you introduce different microphones, they are capturing sounds at slightly different timings. So when the time difference is a lot, we get a phase problem. That means the way these waves are being captured by microphones are slightly different. Like here, we see it's out of phase. It means uh, they are boosting at a certain point and canceling themselves at a certain point. And when they do this, for example, yeah, you have one mic at here, and then next to the person, you have another mic that is picking a bit of the other person's voice and the main voice. That voice bleeds into that microphone, will create this time difference, and it will create what we call comb filtering. So on a graph like this, we already say this is volume and this is frequency. So some will be boosted, some will be cut, some will be boosted. So some, it will create a very funny sound that you you don't like. So you have to watch out for that. As you advance in miking. And then there's places where the microphones are completely out of phase. This means when one microphone is picking the positive direction of the wave, the other microphone is picking the opposite. That is figure C. That means uh, they will cancel. So you will have no sound whatsoever because those microphones are canceling themselves 100%. And that's the technology, by the way, they use in your noise cancellation headphones is they will create a wave and then create exactly the same wave and reverse its phase so that they cancel the sound. So you feel like you're in a vacuum. That's basically what that works. So when you're miking and you start having very different microphones, phase is going to be an issue and you have to know how to deal with it. And this is something that takes time. You have to learn how to listen to it and how it sounds. And yes, yeah. So when you are in this advanced uh, use of microphones, you will have a place where you reach and you have to use creative effects, which we have reverb, we have delay. Reverb is basically, think of it as space. Delay is echo. Think of it as echo. You will find these two things. Sometimes some equipment says space. Some equipment will say whole, and then some equipment will say echo. Yeah, instead, but they actually mean the same thing. Yeah. And then of course there are different types of reverbs, there are different types of delays, there are different types of spaces. The same way we know a church sounds different from a theater, sounds different from an office, sounds different from a studio. So those spaces are the reverb will be designed following those different spaces. So as you get advanced, that is going to be very, very useful. Okay. So future of microphones. We seen how they evolved from last class, and we just did a small recap. Everything is in the document. And we are seeing MEMS microphones, which are microelectro mechanical systems. And these are tiny microphones that are highly sensitive and power efficient. So these ones, you don't need to borrow a generator from your neighbor to run one microphone. I don't think there's a microphone that need to borrow a generator, but anyway, yeah, they are very efficient. So that means even your phone can actually run that microphone, and they are the microphones in your phones. They're called MEMS microphones. Then we have spatial audio. Here we have different types of microphones that capture spaces in virtual reality. So where you remember the techniques we used in stereo, we were capturing 2 dimensions, left and right. But when we go into spatial audio, we are getting audio that is 360. So we are getting directionality up, down, front, back, and side. So you have a more 360, and there are microphones that are designed in that way. Then we have biomimicry microphones. So this bio is basically life and real life, and then mimicry comes from to mime or to copy something. So these are microphones that copy biology. So we'll have people, scientists look at small things and they are inspired to create technology that becomes meaningful. So, like someone watches a spider and is like, these guys don't have ears, but how are they able to detect vibration? How are they able to know something is coming, something dangerous, and they trap something? The moment it tries to run, they are like very, sensitive to vibration. So scientists are, this is still in early development though, but they are developing microphones that are sensitive to that level where they pick a very wide range of frequencies. And maybe we are about to find their relevance in today's generation. But as a sound designer, you have to know some of these things, how technology is advancing and how you can use some of these things. Sometimes when you go beyond the range that human beings can hear, you can creatively use these things to create an effect no one has felt. For example, we are below 20 hertz. If you have a speaker that can recreate that frequency, people can feel those vibrations. They can feel them pushing against their skin. They feel that pressure. So if you have an effect that where there's like an explosion, you can actually use your speakers to immerse the audience by one, record it with a microphone that is able to pick that much pressure in the low end, so that when the speakers try to recreate that sound that was captured by microphones, it's actually true and it's bringing that effect to life. And then we talked about MEMS microphones. So these are the MEMS microphones that you see here. And this image that you see here is the new iPhone 16 Pro. And it has these four microphones at the back that create an immersive uh, effect. So Apple has this thing where they have immersive audio, or they call it Apple Special Audio. So they are creating products and tools to be able to capture and record some of these things so that you can experience. So they have the Air uh, AirPods, I guess. So and they are immersive. So if you have them and you can't record the the quality that they can play, it's a waste of time. So they've come up with this, so which gives you like a 360 illusion of an environment, and they are using MEMS microphones. These are small microphones, but they are effective. On top of the iPhone microphones, they also design technology inside that one is able to clean the audio so that the audio sounds as clean as possible. And they have this feature where you actually almost get studio quality level of voice with just simple small microphones like this. So it tells us how much we've evolved with technology to get to there. And then, of course, other technology develops in wireless technology. That is where so I remember I told you guys and I gave you an assignment to read about radio microphones. And so radio is basically how wirelessly we transmit these signals from one microphone to a receiver and then to the speakers without having a cable. And how does that happen? Someone asked me about a Bluetooth protocol, which is a digital protocol. And then this too is we have an analog protocol which uses a wave. So you create a wave and it's like, let's say, Hertz is a number for frequency. So you will see your radios and receivers have this term Hertz, gigahertz, GHS, GHZ. So it is telling you we are transmitting frequencies in this range at 5 gigahertz. And we know that in our smartphones as 5G. So those are technologies. They actually use sound to transmit information. So that's how cool sound is. So even on stage with wireless microphones, this technology keeps evolving where 5G is faster, but the problem is it is short range. Maybe as technology evolves, we'll find ways of extending. But then we also have artificial intelligence. Like I told you, Apple has these features that can enhance your voice, even though it's recorded by small microphones. It can actually sound like you did stuff record in studio. And then we have, of course, artificial intelligence. Right now, we are at a place where we're transitioning to a new era of AI, and the earlier you embrace it as a sound designer, the better. And there are tools that are very smart that can help you in cleaning dirty audio. And one of the tools is this iPhone 16 Pro. We have Waves Clarity VX, that's a plugin made by a company called Waves. We have Isotope RX, that is also another company called Isotope, I guess. Yeah. And then we have Adobe Podcast AI. This one is free. You can just go on their website. If your voice has had much noise, maybe you recorded with your phone and things are not clear, you can go to the website and just upload your audio. It will process and you'll have like a more something that this iPhone is doing. So you can do it on the cloud. Then we then we have DX Revive Pro. That is also another plugin that can do pretty much what Adobe can do. But that is if you are working with audio restoration. As a sound designer, you also restore sounds. Sometimes you have a file that you think is not going to sound so good, so you have to work with it. Maybe you need to reduce the noise in that microphone. So you need some of these tools to help you. Previously, you would go in and combine different tools and achieve this, but now it's much easier with AI and it's way of working. So embrace AI. And then we have a summary of everything, which I have literally been summarizing. So we have types of microphones, polar patterns, components of microphones, application. And we looked at advanced techniques with microphones and trends. Okay, so that would be it about microphones. Maybe before I move on away from microphones, this is where I'll get my first set of questions. Then we go to today's class, which is about software. If you have any questions, please, about microphones.
Yes, I was wondering something. Can you hear me?
Yes, I can hear you.
I was wondering if you have, I'm not sure if I quite understand that. If you have a vocal, you need a vocal microphone, and you have a soprano voice, like a female high voice. Do you need a microphone that is enhanced in treble, in high frequencies, or you need to maybe amplify the lower frequencies, or I don't know. I'm not sure about that.
Yeah, that's a very good question. Yeah, so microphones that are built for the voice, they are actually catering for the human voice, from male voices up to children's voices, for example. So it should be able to capture that range. And usually that range is between maybe 100 hertz to like 17 kilohertz. So let me see if I can bring back the previous slide, and let's look at this. So as you can see in this graph, this microphone can work for the voice as long as you have this range catered for. So between 100 hertz to about 220 kilohertz. Most of my microphones will go all the way to 20 kilohertz, but to about 17 kilohertz is what we can actually, hear as human beings. So even our voice in that range, it should be able to capture things truly. So it's not like we have microphones for bass, we have microphones for, especially for singers. So we have microphones for voice, microphones that are perfect for capturing environments. Then we have microphones that are perfect for capturing specific instruments. So, for example, now a microphone like this can work very well for vocals. Why? Because we have in this range, we say this is where our hearing range is very sensitive. So it will cut through. When there are other instruments filling up different space, we want especially this area because that's where our consonants and vowels are. So it's sensitive to that area. So you will hear things much clearer. So you want a microphone that has a range that can clearly and properly represent 100 Hz to 20 kilohertz. And remember, like for example, on stage, you might have other instruments and they'll cover all these other frequency ranges. So you want something that will stand out after all these things. And I'm talking about instruments. So for voice, the mic is for voice. It will capture all voices. So the best practice you can do is if you have a choir, is get the same microphone types. Like for example, you can break them into two. Now let's take an example of the figure here. They are labeled figure 11 and 12. So this is the ADX51, which is this one, and the C451. So I have these two microphones. I might choose to give these upper microphones to the ladies. Why? Because it is more sensitive to the higher register, and it's cutting some frequencies on the low register. And usually what we have in the low register is the fundamental frequency, but all these other things that we hear are in the high register. So what I might say is the reason it's a choir is because you've broken down the music for different people to sing. So we'll have low range. So the men are gonna take over that, or women with deep voices. So we can maybe say this microphone, I'll use them on soprano and alto. So they will use this microphone because I don't need a lot of low end from them. Then you go here and this one, you like, I will use this for men because I see it has enough information in the bass range, so I'll use this microphone. And then it also has clarity up here, so however much they are deep, they're still going to pop up and be bright enough. So these two you can combine sets where you have this tenor and bass, and then this you have soprano and alto. That could make sense. But it doesn't mean if you only have this microphone, it won't work for bass. You can work with this still for bass, and then you can maybe do a small boost on this in that range to compensate for the nature of the way the microphone is. Yeah, I hope that answers you.
Yes, thank you. I was also wondering about the combining microphones. What you showed us. I was wondering if we could get some kind of illustrations about that, because I'm not sure if I understand well the phasing of microphones.
Okay.
Maybe you can send us a link of an illustration. I don't want to keep the time.
Yeah, I think it's a very valid point. I think I can get you something that we can watch together about microphones phasing. So I wanted to demonstrate some of these things in my DAW, but I couldn't get it to work in Zoom. I'm still figuring out. So maybe next class we'll have my DAW open and I can give you like a clear demonstration between what is frequency, amplitude, and phase, and like how all these things work. So next class, and that's why I need everyone to be with headphones, because some of these things you will not hear if you're not putting on headphones. Yeah. So Just a sec. So just hang on a bit. I get the video and give me 3 minutes. I'll come back and we show the phase.
As Engineer Manzi sorts that, I kindly request that everyone who signs in use your names that you used during the application so that we are able to capture everyone's attendance. Some of you, there is one who is using a Zoom user, so we can't really know who that person is. So that means during the attendance listing, we can't know who has been part of the class. So kindly, as you join and sign in for these classes, like I mentioned in the first class, very first class, always sign in with your right usernames. Thank you. Also, to those who have questions, sometimes you can be typing them in the chat and then we'll be responding to you. Or if there is space, then you can always ask, as Engineer Manzi gave you that window to ask. But if it's really burning and you feel like you might forget it, if you can't note it down, kindly write it in the chat and we'll be able to respond to you. Thank you.
Okay, so let's watch this video. Can all see that? Tell me if you can hear and see what we are.
In phase, it's important to understand how they're different. It will help if you have a basic understanding of how sound works. As you may already know, a sound wave is a cycle of positive and negative pressure changes. A microphone converts those pressure changes into a cycle of positive and negative voltages in a wire. This signal begins with a positive voltage and then continues through a negative voltage. Let's flip the polarity of this signal. Now the signal begins with a negative voltage. Most mixing consoles, DSPs, or DAWs give you the ability to flip or invert the polarity of a signal. It's the equivalent of switching the positive and negative wire in a microphone cable or in a speaker cable. To better understand the difference between polarity and phase, let's imagine identical audio signals traveling through two separate cables. These two copies of the signal are currently in the same polarity. They will add together at the destination. This is called constructive interference. Reversing the positive and negative wires on one of the cables will invert the polarity of the signal passing through that cable. Now the signals are in opposite polarity. When they're mixed together at the destination, they'll completely cancel out. This is called destructive interference. While polarity is a function of positive and negative, phase is a function of time. To help visualize this, I'll put a delay in the second cable path. At the source, the signals are synchronized. They begin and end at the same time. However, one of the signals is delayed. By the time the signals reach the destination, they're out of sync. Audio waves are cycles. The cycle of this wave begins at 0, goes through a positive phase, and then progresses through a negative phase. Just like a circle, the points along the cycle of a sound wave can be charted from 0 degrees to 360 degrees. In our example, the second copy of the wave arrives as the first copy is halfway through one cycle. This means the signals are 180 degrees out of phase. The first wave is negative as the second wave is positive. This will cause destructive interference because now the waves work against one another. A phase shift doesn't always result in a perfect summation or a perfect cancellation. Up until this point, our examples have contained only one frequency. However, most audio signals contain many frequencies. In fact, this highlights one of the most practical differences between polarity and phase. In this example, we have two identical signals, each containing the same three frequencies. Inverting the polarity of one of these signals will cause a complete cancellation when they mix together at the destination. Inverting the polarity of a signal affects all frequencies in that signal evenly. However, a phase shift will affect each frequency a bit differently. Some frequencies will sum together, some frequencies will partially cancel, and some frequencies will perfectly cancel. Remember, polarity is a function of positive and negative wiring, whereas phase is a function of time. If you got value out of this video, hit
So I'm going to show one which now gives you like a real example of how these things sound in phase and out of phase. Just a sec. I don't know why this is not opening. Okay, let me use the same. Can see my window. I think we can. Let's watch this one.
Comb filtering is the result of two or more identical signals interacting at a slight delay. It can ruin the quality of a recording, so it's really important to learn to identify it by listening. To learn what comb filtering sounds like, let's start with a very extreme example. In addition to the fundamental frequency of my voice is also made up of many other frequencies. So, what does comb filtering sound like? If I copy this recording of my voice to another track, the two copies will work together and the overall level will increase by 6 decibels. So, what does comb filtering sound like? However, listen to what happens when I delay one copy. So, what does comb filtering sound like? Due to the fact that the two copies of the signal are equal in level, this example is very extreme. The closer in level the two signals are, the more extreme the interference will be. If I turn down the delayed copy of the signal by 6 decibels, the comb filter effect becomes much more subtle. So, what does comb filtering sound like?
So as you can hear, it sounds, this one is an ad, don't worry. But it sounds very metallic, like it sounds like Cybertron if you watch like sci-fi movies. So it's this robotic kind of sound because some frequencies are canceling, others are boosting each other. Okay, so copy this link and you guys can watch it later if that is okay. But you get an idea of what it is. This is a good channel, Audio University. It's not just any YouTube that you land on and people will teach you about sound. It's a channel that interviews professionals. It's a channel that has really good information. I recommend it. So you can check it out.
Thank you.
Yeah, you're welcome. So we good with this? Okay, so we are. Oh, did I close the other? Okay, so if there's no other questions, maybe we can dive into DAWs. Yeah, so this session, I'll take it and I'll leave about 10 to 15 minutes at the end for questions and discussion. Yeah, so DAWs, these are digital audio workstations. And we are looking at them in context of sound design for theater. So what are DAWs? DAWs, digital audio workstations, are softwares, platforms used for recording, editing, mixing, and producing audio. They provide a comprehensive environment for audio production and integrating various tools and features that were traditionally found in a physical recording studio. Yeah, so basically these are softwares that are mobile studios. Think about it like that. So traditionally, studios used to have like big desks and consoles and outboard gear. So you have different preamps, you have different tools like compressors, equalizers, spaces, reverbs, delays, all those things. Like you walk into a studio and it's really, really packed with all this equipment. Of course, one of the downside is they were very expensive. They're also hard to maintain. And so as technology evolves, people come up with ways of being more efficient and faster and also delivering high quality. So that's how DAWs came in to solve that problem. Because if you had done a song and you had recorded your project of sound design and you had hired a studio and your time got done and you went away, maybe someone else rented the studio just after the hours you had paid for, they will change everything you had done. If you get more money tomorrow and you come back, you have to recall everything. So that means you go through all that analog equipment that is in the studio, recalling, remembering, where did I leave it? So you get knobs, you take pictures. There were those sheets known as recall sheets. So you take different pictures of all those different things, and then you come, you're like, hey, where was this knob at 50? Put it on 50. The fader, where was it? Let's push it and put it exactly. So it's very time consuming. By the time you're set up, your time is almost done. So you work again for 2 minutes and you'll pay again tomorrow to come back and recall. So that's how it was back in the day. And then DAWs come to solve some of those problems that it's digital. So where you leave it tomorrow when you come, that's exactly where you'll find it. And they are versatile. They are into that. We shall see their importance. And these that you see down here are some of the examples of DAWs that are popular. So we have Pro Tools, Logic, Ableton, FL Studio, and Cubase. So this one here is Pro Tools. It's one considered to be an industry standard for sound designers, and the first one and the last one, they are usually like the best for sound design. Okay, that is Pro Tools and Nuendo. This one is called Nuendo. And then we have Cubase right here, which is a sister to Nuendo. Then we have Logic, which is also good for music and composition. Cubase 2 is good for music and composition. FL is good for making beats and sound design as well. All of them can do sound design. So some of these are free, like Audacity and BandLab. So these two are sisters. That is Logic and BandLab are sisters. One is a lesser version of the other, and but all of them can do pretty much the same thing. You just need to know how to use them. So key components of a DAW, we have a mixer interface, we have transport controls, we have plugins, and we have audio editors, so MIDI sequencing. So these are different things that the DAW should have, like at least every DAW should have these things. Mixing, you've recorded different sounds, you have to mix them, put them together. Transport controls, this is play, stop, pause, record, jump here in time, like that. Then plugin architecture is the DAW you're using able to support what we call plugins. We'll learn more about plugins as we go into advanced sound design, because we are about to start on our sound design project. So we'll get so much more into that. So then we have audio editors. Of course, you've recorded audio, manipulate it, cut it, stretch it, move it around, all that is DAW should be able to do these things. So before we go anywhere, this must be in DAW. And this is the editing window. So everything you're working on is in the editing window. So you'll have everything on this timeline. So here, usually this counts for music, it's bars and beats. For sound, it's time code and seconds, and sometimes also frame rate. So everything will be on this horizontal line going into this direction. Down, it's your tracks. So everything you see here is something they've recorded, it's something they've sequenced, or something that, you know, is in the project. So everything will get stacked up like going down like that. Shouldn't start doing sound effects on the mic. Yeah, so then we have the mixer. The mixer is, you have these are called faders. So you can fade in, you can fade out in the mixer. So it helps you to bring things up, bring things down. And then you can see here, there's a matrix where you can send things to certain places. You can add in what we talked about as plugins. For example, once a channel is used and you want to add an effect, you can use a plugin. So a plugin is a tool that you add to enhance the functionality of your software. So you just plug it in so that it can increase the functionality of your DAW. So for example, it's a mixer and a mixer just mixes sounds, but then you want to control dynamics on some instruments. So you can use something called a compressor. So that tool called a compressor is also known as a plug-in. So you plug it into your mixer so that it can enhance the functionality of your mixer so that it can be able to handle dynamics really well. Then we have key editor and MIDI. This works for music, but it can also work for sound design. Like if you have certain sounds that you're playing with, you can program them and put them on a keyboard or on any other MIDI instruments. And then when time reaches, just instead of coming into the software, open what, and then you just press one key on the keyboard and it gives you the effect. If it's an explosion, just press one button and you get your explosion just like that. So I've explained some of this. The user interface, that is the screen, all these things you are able to see. Everything that pops up on your screen is your user interface. So that means the way it is designed, yeah, that is your user interface. That is how the user is able to interact with the computer and the DAW. So it could, yeah. So, and under the user interface, you have the arrangement view, which we saw, the mixer view, and the transport controls, which we also saw. This is my Keybase project. Let me share it for a moment. It says share with sound, but it doesn't come with sound, but you will be able to see. This is, I use Cubase a lot to do so many things. So what you're seeing is transport controls. So this is transport controls. Now it's playing. See this green button, it's playing. Stop, it has stopped. Record, it will start a recording. And nothing is happening because the track is not ready to record. Now it is recording. Okay, so and then we have loop. So for example, I've recorded this section and I want it to loop that area. I will easily do that and it will loop that section over and over and over and over. So that could happen as I add other, things just below. I could add another audio file. I could add another audio file as I am listening to the other one, and then I could also record them simultaneously at the same time. And as you can see, it's also recording. It's actually recording my voice. Okay, so that is this. These are called tracks. So you'll have all the tracks in your project here. So here you'll have all your different microphones and I'll come back to this. Let me go back to our DAW window. Oh, our presentation window. Okay, so what you saw I was doing, I was interacting with the user interface, and under that we saw these. And then we also saw recording tools and MIDI recording. We didn't show that, but I'll show it. And editing tools. So we have audio editing and MIDI editing. So before I go to this, I'm going to show you something. Let's go back to this window. So editing tools. If I've recorded a file like this, unfortunately, you won't be able to hear what I did because for some reason I just can't share the sound through Zoom. And there's another method, but it will take so long. So, but I want you to see when you see this meter going, this one here, you know sound is actually coming out, or if you see anything happening there, you know sound is coming out. So I'm going to record my voice and I'm going to delete everything. Delete, remove selected, yes. So when you open a DAW that is advanced, it will open empty, and usually they'll give you ways that you can add tracks. So for example, I want to record my voice and I will be beatboxing. Unfortunately, only me will be hearing. Okay, let me find a way to do this. Let me loop it so that Zoom can play it back. Let me look at my settings. Just give me a few. I want you to hear some things. So help me remove that cable and put it in channel 2. Audio channel 1. Yeah. So I'm going to switch to mono audio so that things don't
Excuse me.
sound in. Yes, please.
I did not really understand what means loop.
To loop.
Yes.
Okay, so to loop, let me just give me 1 second. I'll see. Let me see if I can get something through Zoom. I want you to go out mono. This is my voice. 1, 2. Okay, sorry, I just need to. 1, 2, 1, 2. So to loop means this thing will keep going on and on and on and repeating. So if I wasn't looping, this is what was going to happen. Just a sec. I think let me make sure I'm getting sound through Zoom, which is and I don't know why Zoom doesn't have this feature. Zoom audio. Because I'm on channel 2. Just oh, maybe it's unmuted too. So you hang on just a little. 1, 2. Wait. It's because 1, So 1, 2, 1. So what you're hearing right now is I created a loop back that when my DAW plays, you'll be able to hear it. So it's a mono signal, but it will show us something. So what we have is a recording. I'm going to repeat this whole process so that I don't lose anyone. So I'm creating a track. Since I'm a human being and I have one mouth and one throat, I'll put my name here. It's called Joseph. The configuration, this is a mono track. So you have many different options that you can create. This is a mono track. It's one source, and here you can choose the input. So on my audio interface, the microphone I'm speaking through is going to channel 1. So this is what you see here, analog 1. So I'll click there. So that I'm telling the DAW, pick this signal source from channel 1, and I want it to be mono because it's 1, and I'll name it, and then I'll say add track. So when I add track, nothing is happening, nothing special, until I say, this says prepare the track for recording, or it says enable, record enable. So you enable this track to record when you start recording. It's not recording, it's preparing the track to be able to record when I'm ready to record. And then, but if I want to really confirm if the audio is coming into the DAW, I'll click on this feature called monitor. So monitor will tell me, oh, you're receiving signal or you're not receiving signal. Let's see whether I'm actually getting the signal. Check 1, 2. You see, I'm receiving signal, right? Yeah, so, but I'm removing it. So if I want, I can record while I'm monitoring, but usually the problem with computers is by the time they process of me hearing it in the headphones, there's a small delay and it might affect me if I'm working with time-sensitive material like a song. So I don't want to be singing Baby Jesus and then the voice, I'm hearing it after 2 seconds because the computer is processing and then bringing it back. So sometimes we don't use this feature so much. So I'm going to answer the word loop. So I'm going to record and say, so 1, 2, 3, 4, 1, 2. So I wasn't looping. If you notice, when it reached here, there was when I reached here, it continued. But if I to start from here and end from here, and I press loop here, and let me create another track, exactly the same track. So I want my signal to come from channel 1, and it will be mono, and it will have my name 2. It will be, now I've already recorded this. I don't want to record on this first track. What am I gonna do? Let me remove the record enable on the first track so that I only record on the second. But I want to know, okay, what's happening? This time round, I want to loop so that I can know when to enter again. 1, 2, 3, 4, 1, 2, 1, 2, 3. Okay, so there's a timing issue. Let me just make sure it's cycling, it's looping at the exact end of the bar. So 1, 2, 3, 4, 1, 2, 1, 2. Now, that is called looping. It's repeating itself over and over. And I could 2, 3, 4, 1. Let's see what we can do. 1, 2, 3, 4, 1, 2, 1, 2, 3, 4, 1, 2. We could repeat this over and over. Let's say just 3, 4, 1. I hope you're hearing it enough. If you're not, I could also use a plugin. So now I'm going to use a plugin to enhance the volume so that you can be able to hear more. So I'm going to go. Everything I'm recording is coming out through this channel called Stereo Out. So I'm going to put a limiter there. So this is like a compressor. So if I do 1, 2, 3, 4, 1. So you should be able to hear it much louder right now. 1, 2, 3, 4, 1, 2. Yeah, so usually it's not advisable to have plugins on your when you're recording because they increase the processing power of the computer and create delay, and you don't want to be behind. So we have track 3. Let's see. We are looping. 3, 4, 1, 2. 1, 2, 3, 4, 1, 2, 1, 2, 3, 4, 1, 2, 1, 2, 3, 4, 1, 2. Okay, so that is I've looped that section, and you've seen the purpose and impact looping had. It helped us to record on top of what we had recorded before, but in time, and it gave me time to prepare myself to jump in at the right time, and the singing kept on going. Okay, and yeah, so you can continue to do this depending on your creativity. Go on and on and on and on. So maybe we can do beatboxing. I'm not a good beatboxer, but I can try. 2, 3, 4, 2, 1. Okay, cool. 1, 2, 3, 4, 1, 2, 1. Yeah, really bad job there, but yeah, it demonstrates what it can do. So when you're familiar with a DAW, you'll do so many cool things, and it just you should get familiar to it to a point where it's just your second language, so you can express yourself much easy. So now I've recorded those things, and I need to mix them. I need them to sound good. And maybe I can actually use this to also demonstrate what phase is going to be. So when I zoom in here, you can see the timing. These guys are going in the same direction. But let me duplicate one voice. 1, 2, 3, 4, 1. So those without headphones, I'm really sorry, but yeah, if you get headphones, you'll hear this. So when I double this voice, we got a boost in volume. We got more volume than we had before. 1, 2, 3. But if I, guess what? If I change its phase, let's go into tools and say invert phase. Let me zoom in. So do you see that when this one is going down, this one is going up? So they are going in opposite directions, right? You with me?
Yes,
All right.
yes.
Okay, cool. So when I play them both, I'm not going to hear anything. They're canceling each other out. And if I turn the volume of one down, I've created a difference in these two, and you will hear something. 1, 2, 3. When there's just a difference in volume. Let me put it back. You will hear absolutely nothing. Nothing. If I mute 1, 2, you hear the voice. 2, 3. Unmuting, it just cancels itself. So this is called phase cancellation. So it's 100% canceling itself. So what the other guy was doing by delaying one channel, as he was showing you, is let's slightly move this. Let me put back the phase where it was. So now you see they are still the same, going in the same direction. When this is going up, it's going up. And but the time has changed. So one is slightly in front. This time difference can happen because one, you have two microphones pointing at the same source, but one is slightly far. So once it is happening, one, you're going to have that metallic voice. Let me exaggerate it a little more. 1, 1, 2, 3, 4, 1. So it's comb filtering. Some frequencies are canceling, some are boosting, and it sounds like I am a robot. But as a sound designer, I could actually use this as an effect, to create something cool. It's a bad thing, but I could use microphones to actually achieve that sound if I wanted to, create that. 1, 2, 3, 4, 1. Hear how bad it sounds? 2. 1, 2, 3, 4, 1. Now let's remove it and see the original. 1, 2. It's warm and full. 1. So that tells you when you start having many microphones, it can actually bring problems to you because that time difference, because remember, sound has a speed 341. So it's going to travel and arrive at different speeds. And if this is in your microphones, of course, you can come with a DAW. Now, that's why DAWs are cool. You've recorded these things. You'll come and look at your recording. You're like, I can see this is the same signal, but this one is time delayed. What should I do? I can drag this and put it in time, and I'll fix the problem. 1, 2. I'll actually have more volume because they are doubling themselves. So these are some of the cool things that you can do as a sound designer. I've answered the question of looping. It's if I remove looping, when I reach the end, it will continue playing continuously up to infinity. Okay. So basically that is it. And then if I want to mix, let's delete some of these tracks. If you want to mix these things together and have a very good song with a bad beatboxer and a bad singer, we go into mixing. This is our mixer. What you're seeing here is my microphone. So, but let's play. Whoa, doesn't sound good at all. 1, 2, 3, 4. So many problems I'm hearing. One is this guy is not on time. He's cool. He can beatbox. Yes, we love him, but he's not on time. And one of the things you can do is, with a DAW, is you can do time stretching. So this is where you can correct some of these timing issues, like you're seeing. It sounds so bad because one, the time is not good. Two, the beatboxer is really bad, but the tools are good. They say a bad workman blames their tools. So let me go in and snap everything to grid, and beatboxer should sound a little fine. 1, 2, 3, 4. 1, 2. So towards the end, he's not good. So, yep. All right. So I'm not going all the way like to make it tight, but we will go into all this. And so I want to go to the mixer and mix this song and make sure this song sounds good. So I want to start with the drums. I think they are too dynamic and they are too loud. Well, one of the best ways is I want to control this problem from from the source, and I will control it from what we call gain. We talked about gain last time, and gain is input volume. So I'll turn the gain down, which is here. Oops. Let's turn the gain down. It is this one. Now it's a little quieter. And I can hear, because it's a DAW, I can hear one track at a time. I've done a multi-recording at different times, so I can hear one thing at a time. 3, 4, 1. So yeah. 1, 2, 3, 4. 1, 2. So I can be like, do I want to hear the lead more? And I turn the backgrounds down. 1, 2, 3. So I'm using faders to create a mix. 2. And then I can use EQ to 1, 2, 3, 4. To enhance the bass, maybe. 1, 2, 3. If you're hearing in headphones, if I boost here, I have created more bass in the beatboxer. 2, 3, 4. So this is called an equalizer. So these are the tools. I am just going to scratch the surface right now because we were going to start working on something together, and we will dive so much into some stuff. So I've demonstrated what that is. I'm going to take us back to our slide and we run through because, yep, cool stuff is coming. Tell whoever is planning to dodge the next class that you are missing and you don't know. Okay, so yeah, they shouldn't miss. Why would anyone miss a class about audio? I don't get it. All right. So we looked at editing tools. I've edited something. I've time stretched certain things. I didn't cut, but yeah, it was possible. So components. So we have virtual instruments. This is where I can add in like a piano to this. It's not a real piano. It's a virtual piano, and we call these virtual instruments and samplers. So I could actually get my voice and make an instrument out of that. We'll see how to do that next time. That's going to be cool. Then we have mixing tools. We saw faders and panning. Panning is you can move things to the left, you can move things to the right. If you didn't do it while recording, you can do it now with your DAW, with your software. So cool stuff. And then we can add effects. If I had added effects, oh my God, some people would ask me to release an album of 1, 2, 3, 4, 1. But yeah, it makes it sound much, much, much better. Okay, so we have what some of the components. So the DAW should be able to export, should be able to integrate with other tools. Like now I have a microphone. The DAW should be able to integrate with my microphone. Otherwise, what is it good for? Absolutely nothing. That's a song that old people like me know. Yeah. And then we have importance in theater. Sound design. Why is it like DAWs? How are they important in theater. So we need them in creating, manipulating sound effects, music, dialogue, Yeah, so the sound designers will use them to create an immersive effect and, like that song where it sounded like the angels were singing for you guys. So it was being done by a sound designer who recorded an amazing singer and a beatboxer, and it sounded heavenly. So now we look at sound design in theater, the role of sound design. These are things you must always remember. We are there to enhance the narrative. So if it needs music, think, how is this music going to play? So is my sound system able to play? Or your sound system in theater is a radio. And you have hip hop music that needs a lot of bass, or you will have a beatboxer. Yeah, so you must be also able to create an atmosphere as a sound designer. And very important, support the emotional journey of the story. So if there are explosions, make sure you have the explosions. If there are feet, you can do the Foley, you can do, make sure the audience is like lost. And the best way to do it is make sure they don't even notice that those things are there. That's how you know you're a good sound designer. People just get lost in the story. They don't even think about you. So prepare from right now. Like I am very prepared that no one will thank me for singing for them. But yeah, that's how it is. Like you sound, you do a great job. No one is going to notice. And why? It's because your goal is to make it so real that no one wakes up in the morning and thanks the flowers for looking beautiful. Actually, they give credit to God. Yeah, yeah, thank you, God, for the flowers. But also, maybe the flowers tried that morning to look pretty and you just passed by. But it's because in your mind, flowers are supposed to look beautiful. Yeah, so you don't thank them every now and again. So, sound designers, you do a great job. No one's going to thank you. Maybe your hobbyists and people who know something about sound will thank you, but the rest of the world will like, yeah, that was a good show. Yeah. They will never know sound designer ever existed in life. So these are 4 elements that you need to know as a sound designer that are very important in making the story rich and real. 1, dialogue. Very important. Everyone is coming to listen to the story, and usually it's in dialogue. Then we have music, the emotional enhancement and journey that they will make you want to cry. Ooh, in the music, and it should play with high fidelity. So set your system very well. Your playbacks, they are arranged and they are timed. It's very important. And then sound effects, doors closing, footsteps, all these things have to be. And here we have diegetic and non-diegetic sounds. And when we have diegetic sounds, these are sounds that are in the story, that are in the world of the story, like footsteps, doors closing. The characters are interacting with those objects. And then with non-diegetic, these are sounds that we can add as sound designers to enhance, to make the drama real. Okay? Yeah, if the woman was angry with the husband and they slapped them, yeah, make sure they slapped the hell out of them. So it will create this thing where you will hear this slap and it will be thunderous. You'll be like, did she use thunder? Yeah. So to create that like dramatic effect, you need to use sound design, and then people will like, whoa, he's dead. Okay. So that's like the automatic response. So as you're not speaking, but your sound's actually telling the story. Then ambient sounds, these are backgrounds. You have to place things in an environment. We are in UK. What do we need to hear? Trains, cars, And then we are in Africa. Stereotype. I'm from Africa. And where I am, there are no trees and birds. But media thinks when you're in Africa, there are birds, cars, there are no cars, there's animals that we use for transport. No, we don't. So, and then we have script analysis. This is a very important thing. Yeah, these are very important things. So we have script analysis. You have to understand the story. You have to understand the story and analyze it and know what sounds do I need to use. Collaboration, you need to, discuss with the actors, with your director, so that you know what sounds you need to collect um, for the project. Okay, so these help you as a sound designer. You're not the only one who knows what works. It's remember the vision of this whole project is the director. So please listen to them, collaborate with them, and be nice. Like shower, brush your teeth, because you'll be talking to some key important people who will hire you next time. If you bless them badly, you might lose your career. So those are key things. I think ISMA will handle communication and branding. These are very important things because you're collaborating. Man, yeah, look good, look good. And then we have recording and editing. It's your responsibility to record, edit these things, make sure they're ready. The director is not going to do this. The actor is not going to do all this. It's your job as a sound designer. And we use a DAW to record, edit, and do all these things. And then live mixing, we can actually integrate DAWs into the live show where we trigger certain things in real time. And so we have sound design techniques. EQ, what I did there where I pushed some curve up and I said, miracle, there's more bass. So that is an EQ that does that. Okay. So that is equalization. It's something that takes years, some years. It can take short time, but years to really master and learn to hear and to use it correctly. EQ or equalization, but short term EQ. So we use it to enhance, to create drama, may sometimes make things larger than life, Yeah. There's many other roles, but yeah, you must know how to use it. Then dynamic processing. What I did there where I said you guys were not hearing me very well and I turned on a plugin and it made things a bit louder because I know when people are going to listen to these things, not everyone has good speakers anytime. Like today, some people didn't carry headphones, but they need to hear with their phones, so I had to boost it. So yeah, that is dynamic processing, like you saw. Make things louder, some things that are overwhelming, turn them down. And then we have effects. If I added delay and echo, make it sound cool, that would be great. Then automation. I might not be in a DAW all the time. I can set these things and create automation so that even when I'm not there, the computer can actually, at a certain point in time, can turn things up and then turn things down automatically. I just have to supervise it. That's the beauty with digital, which is not in analog. You have to be there all the time. Or create a very big machine that is going to make things automatic, a machine that is like a human being. Ooh, good luck. So, and then layering and soundscaping, you put multiple things together so that you have a convincing environment. Okay. And then we have Foley. We talked about Foley. So Foley is basically a reproduction of everyday sounds that we add in production to enhance the quality. So we have like footsteps, maybe we have things like thunder. So things that are in the environment of the story and how those actors will interact with them, we call that Foley. I don't like the definition that says it's the human interaction with objects. I mean, it works, but usually many people define it like that, but it's even more than just that. There are certain sounds that are just existing in the story that are called Foley. So we have specialization. This is creating space. Okay, making things more real. So we have like Dolby Atmos, we have things like that to make things move around us. And so we can only achieve some of these things by preparing some of our files with DAWs. And then, of course, sound design for transitions. Like I can create a transition right now, like by going like, then that would be like a good transition, and I could record it with my voice and then enhance it with other tools, or I could actually use synthesizers to create some of those things, or I can take a microphone and record wind and then automate the volume, start soft, and then grow big, and it creates a very big sound effect. And then interactive sound design, sometimes there are tools that we can design props that when an actor touches that prop, like a gun, it is synchronized with a DAW or with anything else, that when they touch it like this and they click the trigger, the sound effect will trigger itself. Okay, so I don't have to be there as a sound designer to do so. I can integrate that into the props that are actually in the play. Then we have voice processing, which is basically working with a voice. So the workflow is, let's say you have a scene for a marketplace. One of the first things is import dialogue and then bring the ambient sounds of the market and add footsteps and then background. Why is it like this? Start with the most important thing. There's dialogue in the market. As long as we understand, dialogue can actually make us understand that we're in the market. But we want to make this even much cooler, so we'll add effects. But the most important thing is not the effects, it's dialogue. So we must listen to dialogue. So get the dialogue sounding good. Next, where are we in the market? Get the ambience of the market, blend it in so that it doesn't overwhelm the dialogue, and then add footsteps and other things that add color to the story. And so obviously you'll have to organize your dialogue tracks and all these things separately, and then you start panning things left and right, and then you can equalize to make sure things sound good. So some frequencies are not louder than others. EQ works with frequencies, okay? Or you make sure there was too much noise in the market, let's boost let's boost 1K, 2K, 3K in the voice so that it can cut through all that noise so that we can hear the people speaking. And then dynamics, where we have compression. Some things, there is a bus that was hooting in the market, but it was loud, oh my God. And then you put a compressor, every time it hoots, it just turns it down. That's what a compressor does. We shall see that later. And then effects, you can add reverb to simulate the open environment in the market. Maybe there are buildings and sound is reflecting on those walls, so you can add a bit of effects and reverb. And then you can add automation, like we said before. You can automate certain things when the small motorcycle passes and then later another car passes, so to create movement and cool things to happen. Some things will go up, some things will go down. Then you make your final mix, and then you give that to your audio supervisor, who will give it to the playback team, who will play these things in the theater when they sound good. Yeah. So then practical considerations, of course, as a sound designer and designing for theater, be aware of the space. So yeah, theaters are usually treated, but there are some spaces that are not treated. So you should be able to, establish that. So if the space has a lot of echo, you can use acoustic panels. If there's too much boominess and bass, you can use bass traps to solve some of those problems. And then you can also configure some of the sound systems to make sure they work well in such spaces. We talked about microphone techniques, so I'm not going to explain that. And then surround sound and specialization. We talked about that already. Dolby Atmos, surround sound 5.1. These are entertainment technologies that we have that can bring life to the story. Okay, so yes. Then we have collaboration and communication. I talked about how you need to be smart, how you need to be respectful, attend rehearsals, make sure that your effects are timed very well, and then file management. People think they will record and not back up their files. They forget there's viruses and so many other things that could easily happen and take your work away. So backup, always backup. Buy space online in the cloud. Buy an extra drive where you can save some of those things. Then technical considerations, there's latency and synchronization. These work so much if you have a picture involved in your theater play. You have to make sure that your actions, every sound is synchronizing with whatever is actually happening on stage. Then budget, of course. Some directors are very good visionaries, but they are not realistic at all. So they might think you might create the sounds of heaven. Yeah, you will need the voice of Angel Michael. You need Lucifer screaming, but God will not open the door. But we want to create this effect where we can hear people crying in the background and then angels up there singing hallelujah. So just create that. Then you're like, I need to go to heaven to record this. And then the director is like, no, we don't have that kind of money. You're not going to heaven right now. So you need to be smart, work within your means, make sure Angel Michael maybe visits you in one or another. But one tip about Angel Michael, he doesn't take bribes. Yeah, so you just have to make things happen. And then practical considerations, ensure that your sound design is accessible to all audience members. They are all hearing. There are some people who can't hear properly. So you need to be at a sweet spot where you're not too quiet, where people struggle to hear, and you are just at the right level. That's when it comes to volume. And there are examples that I'm putting down here so you can read them all. Then we have legal issues. Yeah. So don't use things that don't belong to you. That will bring a lot of problems. So today we've been able to talk about DAWs. So sound design has different experts and different things that we do, but then we have DAWs. Sound designers can craft immersive and dynamic auditory experiences that enhance the storytelling and impact of the performance. Key takeaways: understand DAWs, sound design techniques, mixing workflow, and practical considerations. Those will take you a long way, like we've come. Thank you for your attention, and I look forward to any questions, discussions you might have.
I want to thank you on your inspired talk. And I have a question about those recording in heaven. What I mean, it doesn't have to happen to you, but what you know about the most strange instruction from director, or what you wanted to do, but it was very hard to do. I mean, to go to heaven to record something.
Oh yeah. So honestly, you can't go to heaven. You could, I don't know, but for a project when you're sent by a director, it's impossible. So what happens is you engage into a realistic discussion, and you're like, what material do we know about heaven? What material do we have about heaven that we can read and get inspired to create a heaven sound? So you're like, maybe this religion teaches about heaven. Christianity, Muslims also have something about, so you get all that information, and then start on like, okay, what characters are there and how can I create this world in a simple way. The best way to do a big overwhelming project is by breaking it down. What would be the ambience in heaven? Do you think it's quiet? Let the director tell you what they think heaven is, because I mean, you can say what I know the angels are singing. Maybe they are singing 24/7. I don't know. Maybe that's the background. Or I've heard other people who have said it's a beautiful place, the birds, and it's peaceful. So maybe I could borrow from people who do Zen. Maybe they do it because they're inspired by that peaceful state of mind where you hear ambience and quiet, calm music. So you go into imagination, but you see, approaching it needs research. You have to research. You need to know about what makes people feel calm and peaceful. Do we want to create heaven as a threatening place that has a like scary glory of God, or do we want to create a calm place that makes you feel comfortable? Then that will guide your decision making. Either you're going to go all the way where it's grand, you hear like a big horn like that, and then angels will come in, and then they sing and sing and sing, and then maybe you might go. People with phones are not hearing these things, but yeah, you just a simple quiet calm wind or just a soft birds. It's morning, the sun always shines in heaven, there's no darkness, so you create an environment inspired by some of those things. But you keep checking it with the director. You go and ask, do you think this will work? And they're like, yeah. And then you're like, based on the timeline we have, we actually don't have a lot of time, but I think we can borrow from Zen. They create music for meditation. Maybe we can recreate something like that to symbolize heaven. If they agree, you win. If they don't, I don't know. But you have to make it work. There is no I don't know. It just has to work. So communication usually makes things easy. Yeah. So communicate, keep communicating with the director. Do soft, simple things and communicate. Don't wait to do a whole heaven scene and you're like, come and check this out. And it's like, hey, I had a car. You're like, heaven is both the future and the past. There are cars there. And in his mind is like, no, 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 no. So you remove you see, it will save you a lot of time if you just did the background. Listen to this wind. And then, like, actually, that sounds so good. And they're like, how can we add birds? I think that will be good. Maybe we can add simple music in the background. And they're like, yeah. And they're like, I think we made heaven.
I agree. Thank you.
Yeah. You're welcome.
I have another question.
Yes, please.
Maybe maybe I should write down those questions for you, because there are something like concerning equipment.
Yeah.
And I can say it now, or I could maybe write them in the mail.
Yeah. It's okay. You can write. I think you if everyone is okay for us to go like 10 more minutes, you can raise your hand. If you're not okay, maybe. But we're just answering questions. I think if it's okay with everyone, we can extend 10 minutes. If you don't agree, you can put. Okay. If you agree, put your hand up. Okay, we have 2 people. 3. Okay. So I don't know if we can do this. All right, cool. Okay, we have enough quorum, I guess, so we can answer the questions, and at exactly 8:10 we are done.
Okay. I was wondering if we have it's the talk about the budget.
Yeah.
Are we supposed to have our own equipment, or to ask for the equipment or for the budget to acquire some equipment for the performance that we are doing? Or is it, I guess it's done in both ways, like this
Yeah,
first
so
question.
okay. Okay, the next question.
The next question would be, if I wanted to record ambient sound, I know I can acquire them from the internet, but if I wanted to record some specific sounds that I wanted to use for a performance or something, what recorder would you, suggest to buy?
Yeah, it's a
That's
good one.
the second question. And the third question was concerning lavalier microphones. Can we use some hands-free microphones to be connected to some kind of processor, vocal processor? That's the last question. I don't know if
Okay.
I was clear.
Yeah, so for the last one, it's the one maybe I could get more light on it. Lavalier microphones, can they go through a vocal processor? Is that the question? All right, so yes, yes. The answer is yes. So vocal processors, what are they doing? They can be adding effects, because remember, these characters are happening. I might want to make them sound that they were like they were in the cave. So these lavaliers will go through a vocal processor, and I will add that effect like that. That's the only way I have, uh, I can do that. And then about equipment, as a sound designer, yes, you must have your own equipment. Certain things you need recorders, you need a computer, you need certain things like to always be, they are your tools. And remember, you're practicing over and over, so it is these tools that will keep you growing. First of all, if you don't have a computer, you don't have a DAW, and it's very easy to tell the project director, I need a better computer because this project is going to be bigger. I already have a computer, but it will take me more time. But if you can facilitate and we get a stronger computer, we might do some of these things much faster and better. It's better. It's easy for them to support you. But if you have zero, it's going to be very difficult. So have some equipment for yourself, and then you can easily enhance the equipment over time. The third question, which was the second question, was we had lavaliers, we have equipment, and what was the third one?
The third one was about the recorder of the ambient sounds.
Oh yeah, so
or some live performance.
Okay, so ISMA here is a field recordist, and that's like one thing he does over and over. He knows them much better, but affordable options, you'll have the Zoom H series. So from the H4, H5, H6, H8, those are a good place to start. If you want to go higher, I think also Tascam has some good recorders in that range. If you search the Zoom H6, they will suggest a Tascam somewhere that is in that range, and other recorders. But you want to have a recorder that can be able to record high resolution. So any 24-bit and above, 32-bit preferable. If you're a sound designer, you record at 32-bit. So the recorder should be able to support that. And I think, yeah, and sample rates. So there are different sample rates. We have 41, which is okay. But as a sound designer, you need something that records 48K and above. So we have 48, 96, 192. Those are the recorders you should go for. And then from there, you will decide depending on how many inputs you want to record. If you want two recorders, a stereo recording, Zoom H6 with its own kit, it has a really nice stereo mic. It can give you great ambience. and it's affordable, it's cheap, then yeah, I think that answers your question. And we have 4 minutes.
Thank you so much.
Yes, and to add on what Nimaza said, yes, the H series is really perfect because they have like onboard microphones. The H4 has a stereo pair on, the H5 and the H6. Similarly, it's the same with the H8. So the Zoom H family is perfect for you. What varies is the number of inputs. And that's why he said if you need to record, let's say, more than 4 channels, if you're recording 6 tracks or 8 ambient tracks, that's when you'll choose to go for other recorders like the Zoom, the F. If you're still in Zoom, you'll go for the Zoom F family. That's the F8, F8N Pro, or you can use the Mix Pre's. You can go to the sound devices. You can go to the counters, depending on the budget. And also to add on the what you asked about equipment hire, always as a sound designer, when you are approached by the director, know what you have, but after doing a thorough analysis of what you need to really capture and what you need to use, be able to draft a working budget. Share that working budget with the production. Then they can tell you that we can afford this or we can't. If they can't, then you have to devise means between you and the production, be it the director or the producer in most cases, because it's the producers that sometimes handles the financial side. So discuss with them and come to like a normal agreement, like a working agreement, where you'll be able to get something that is usable for the production. Thank you.
Thank you. And is it possible to create some kind of list for us to maybe think about buying something like that?
Yeah, sure. We can put that down. Next class.
Thank you.
You're welcome. So if there are no other questions, I want to thank everyone for attending today's class. If you had a question that can overlap to next class, please write it down, or you can actually send it in the mail, and we'll think about it. And yeah,
I see Shukra has a hand up. Are you saying something?
I think she raised it during the put your hand up if you can go 10 minutes more.
Okay. Thank you guys. And I kindly request, let's get the headphones. Let's get the headphones, because that's how you'll be able to listen to these other extra details that are being played during the class. Okay, that's how we'll be able to tell the difference between the highs and the lows, or whatever adjustments that we want to experiment on.
Okay,
Till
thank
next
you.
week on Sunday. Stay blessed.
See you on Sunday.